Okay, so as we spoke to in a previous video on scatter plots, a scatter plot is a graph of plotted points that shows the relationship, if there is one, between two sets of data. Well, in this video, we're going to talk about correlation. And our objective is we want to determine the strength of that relationship, which is called the correlation. Okay? How strong is this relationship between two sets of data? That's what we're after here, okay? So if there is a relationship, we want to know how strong is it and in what direction it is, which we'll talk about as we go through the examples. So our topic, correlation. Well, what is correlation? Correlation is a relationship between two values. Okay, when the correlation is positive, that means that the values increase together. For example, height and weight. As height increases, weight increases in general, okay? If the relationship is negative, that occurs when one value decreases as the other increases. Okay, here's an example. This one is the value of a car. Okay, as age increases, as cars get older, their values decrease. They're worth less and less. So that's an example of a negative correlation. Okay, correlation shows both strength and the relationship. Okay, correlation is designated by the letter R, and it has a value between -1 and 1. So we're just between -1 and 1, from -1 to 0 and then back to 1. And this value is called the correlation coefficient, this letter R. If it's a -1, so it's totally to the left, -1, you have a perfect negative correlation. If it's +1, so you're totally on this side, you have a perfect positive correlation. And if it's 0, you got nothing. You got no correlation at all. The values don't seem to have any relationship. An example of no relationship, how about shoe size and intelligence? You know, the size of your feet have nothing to do with how smart you are. So there's an example where you're going to get an R, a correlation coefficient, very close to 0, because there is no relationship between those two values. All right, so I have a little graph here I got from the internet. A correlation is assumed to be linear. It's assumed to follow a line, as we're working with this in scatter plots. And these are by no means, these examples here are by no means the only ways that you can divide this up. This is just how one website divided it up. But, you know, these three are given. A perfect positive correlation has a correlation coefficient as 1. It is extremely strong, and it's positive. It goes from left to right. As X increases, Y increases. So it fits perfectly on a line. Similarly, for -1, there's a perfect negative relationship. As one value increases, the other decreases, and it fits perfectly on a line. There are very few cases of perfect positive or negative correlation with sets of data. So those are our extremes. And then, of course, in the middle, you look at these data points. There's really nothing you can see here. There's really no line being developed in here. So we say there's no correlation. Again, shoe sizes and your intelligence. You know, large shoe, low intelligence. Large shoe, high intelligence. Small shoe, low intelligence. Small shoe size, high intelligence. And everything in between. Nothing going on. Between these extremes, you can have a high positive correlation, or some would say a strong positive correlation, and some use 0.9, maybe some use 0.8 we'll use 0.9 that tells us if it's around 0.9, it's a pretty high or strong positive correlation. We're not perfectly on a line, but you know what? We're pretty close to a line. 0.5, a low positive correlation. You can kind of see it in here that as X increases, Y increases. It's not great, but it is kind of there. Some folks may say as low as 0.3. They may call this a weak positive correlation. It just depends. Okay, different books and different people will say slightly different things. And then on the right side of here, we've got a low negative correlation mirroring this side, negative 0.5. The negatives tell us it's a negative correlation. So we have a low negative and a high negative at negative 0.9, for example. So this takes us from 1 to negative 1, or if you want to go from right to left, from negative 1 to 1. So this value, this correlation coefficient, shows us how good it is, perfect, high, low, no, and if it's positive or negative, the direction. Positive, 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 no, negative, negative, negative. So we have these two things. The strength, perfect. The direction, positive. The strength, low, not very strong. The direction, negative. Okay, we'll see that in our examples. Well, let's take a look. Speaking of examples, I've got two lined up for us. Okay, I'm going to go back, and we saw this example with our scatter plots video, heights and weights. Okay, so here are our 6 people. We saw this on the previous video. Here are each of their heights in inches and their weights in pounds. Now we just know from being alive and knowing basic things that there's going to be a positive correlation. As people get taller, as their heights increase, their weights also increase. Okay, if they both increase together, it's a positive correlation. Okay, the question I have here is how strong is the correlation for this data set? Okay, is it perfect? Is it high? Is it low? Or is there no correlation? We know there's something, so it's probably going to be either perfect, high, or low. In Desmos, the function is called CORR, and that'll tell us the correlation's value, the correlation coefficient. Let's take a look at that. We'll go into Desmos again, and I deleted the table, so we'll recreate the table. Okay, I'll press the plus sign here. I'll come up with my table of values. I put X as the height and Y as the weight. And so the person A was 64 inches tall and 165 pounds. Person B, 66 and 160. Person C, 59, matching up to 138 pounds. Person D, 62 inches, 120 pounds. Person E, 64 inches and 129 pounds. Person F, 61 inches and weighing it at 152 pounds. So there's my table of values. Again, Desmos has a default from negative 10 to 10 on both the X and Y axes. I will press this magnifying glass with the plus symbol, and there's the data. It has rescaled the axes so we can see our data. Okay. Now, we notice that, in general, as we get taller, we get heavier. Taller people are generally heavier. Okay, what's the correlation? We know it's positive. So let's go to row 2 here and go to functions, and we'll select the statistics functions. Mine's already selected statistics. And here's the CORR button. Okay, so press CORR and it pops up over here. And we wanted to find the correlation between the X's and the Y's. Okay, so I wanted to look to compare column X1. So I type in X1 and I'll put in a comma. And I wanted to compare that, go back to here. I wanted to compare that to the Y1. So find the correlation between the X1s and the Y1s. And there you have it. Desmos is telling me there is a positive correlation because it's positive, but is not particularly strong between heights and weights. If I round this to the 10th, I get a 0.4. Okay, so the relationship, the strength of the relationship is a 0.4. Okay, let's go back to what this tells us here. Okay, so here is, oops, I've gone too far, sorry about that. So, in Desmos, how strong? Well, the R is equal to a positive, and I rounded to the 10th, a positive 0.4. Okay, that's not very strong. If we go back to our chart here, and this is just one chart of many that are out there, but this chart tells us, well, we're right around the 0.5 range. So there is a low. We know the direction's positive because it's positive. We know there's a low positive correlation. So we would say this is a low, and this is the strength. Positive, and this is the direction. Correlation. There is a relationship between these data, between these two sets of data. However, it's not particularly strong. Okay? It certainly is positive. As we get taller, we get heavier, but it's hard to make a prediction. It's not a very strong relationship because there's a lot of variation in weights for different heights. So it's not a particularly strong relationship. Okay? If I were to do heights and arm span, we would see that's a very strong relationship. Our heights are very often very close to the length, the distance from fingertip to fingertip, our arm spans. And so as we get taller, our arm spans get longer, and it's a very strong relationship. We can predict very well that if you're 64 inches tall, your arm span is almost 64. Okay, so that's an example of one that would be pretty strong. Let's look at a strong negative one. Speaking of a strong relationship, okay, let's take a look, and this example comes from the textbook. So example 2 here, if I can get it, okay. So here we're talking about years of education and the score on a prejudice test. Okay, and the question is, does number of years of education correlate to how you score on a prejudice test? And on this test, the higher the score you have, the more prejudiced you are. Okay? So a score of 10 suggests you're quite prejudiced on this test. A score of 1 says you are not very prejudiced. Okay, so we looked at, let's see, 1, 2, 3, 4, 5, 6, 10 people, and we each have how many years of education they have and how they done the test. Is there a relationship? Okay, what is the correlation coefficient and what does it tell us? Okay, is there a relationship in this data? Okay, let's see. Let's go to Desmos. And let's go ahead and get out of this table and get out of that row, and I'll go back to the default graph here, and I'm going to again press the plus sign and the table. And in this case, my X column is going to be the years of education. So person A had 12 years of education, and person A's score on the prejudice was low. Not very much prejudice on the test. Again, a low score means less prejudice. Okay, B had 5 years of education and a score of 7 on the prejudice test, a higher score. Let's see here. Person C had 14 years of education and scored a 2 on the prejudice test. Person D, 13 years of education with a score of 3. Person E, 8 years of education with a score of 5. Person F, 10 years of education with a score of 4. EFG, 16 years of education with a score of 1. H, 11 years of education with a score of 2. HI, 12 years of education with a score of 3. And our 10th person J, 4 years of education and a score of 10. Okay, so there are 10 data points, and we see some of them got mapped over here because we're only the ones that fit. So let's again go back to this little magnifying glass with a plus sign to align our graph to our points. And there they are. Well, you can pretty clearly see here that as the years of education increase, scores on the prejudice test are definitely decreasing. We can see if we put a line in here, okay, that's definitely a decreasing line. This is saying to us the more years of education you have, the less prejudice you have, because the lower scores indicate less prejudice, the higher scores indicate more prejudice. And it's, you know, these points, they're pretty tightly together on a line. They're not quite as spread out as they were with the heights and weights. Well, let's see what the correlation coefficient tells us. Okay, how strong? It's obviously negative. How strong is it? So I'll go here to row 2. I'll go back to the functions, and I'll choose correlation. And again, I want Desmos to calculate the correlation between x1 and y1 data points. So x1, comma, y1. And looky here. This is a negative 0.9 if I round it to the 10th. Remember, negative 1 is perfect. So this, at a negative 0.9, that's strong. There is a strong relationship between how many years of school you have and how you scored on the prejudice test. And it's negative with a negative 0.9. So we'll go back over to here. And we'll say that, hey, we use Desmos in here. What is the correlation coefficient? Well, the correlation coefficient turned out to be negative, and I'm rounding to the 10th, negative 0.9. Let's go back to here. And this one actually happens to be on our chart. Here's a negative 0.9. It tells us that the strength is high. It's a very strong relationship, okay? And it's, of course, the sign tells us it's negative. This is a very tight relationship. Obviously, the more years of schooling you have, the less prejudiced according to the test you are. So people with fewer years of schooling tend to be more prejudiced based on this test. Okay, so this is a high, and this is the strength. This is a high negative. This is the direction. Right here with that negative sign, correlation. Okay, a high correlation tells us we can use this. You know, this is significant. Okay, it's pretty clear that as you spend more years in school, okay, as you spend more years in school, according to this prejudice test, you become less and less prejudiced. Okay, that's a pretty significant relationship. So if somebody were to say, you know, we're trying to eliminate prejudice, well, it's pretty clear that what we're looking to do here is get more years of schooling in there for people, because those who had fewer years of schooling did not score very well. Those who had the higher years of schooling scored quite well, you know, in terms of being low, of being not prejudiced. So there you have it. We're now going to put this together, scatter plots and correlation, and talk about regression lines in our next video.